Hi, my name is Noor Ali, and today I will be discussing embedded systems. We want to know what are embedded systems and the tools and softwares used to manipulate embedded systems, right? And platforms, components, and hardware, examples of embedded systems. And I'm gonna be showing you guys a toy car at the end. Here we go. What is embedded systems? Embedded systems can be defined as a system that has been hardware and software built in. It's the art of choosing and determining proper combinations of hardware and software. That's a really good definition. It's like really choosing the type of coding and the type of language that you're going to use that's specified for your requirements. Everybody has a different type of user requirements. So, and then embedded systems are designed to do one task. So, we know that in embedded systems, the whole goal is to have each embedded system to do one singly defined thing. This is kind of can be related to functions, and functions have subroutines, but that's not the point. Functions are defined to do one thing by definition, and so are embedded systems. The tools and software. The type of tools used here are C language. That's the most popular one now. Most common software language to program embedded systems, of course. Most devices, drivers were encoded using C language. For example, if you can remember how we did in our software engineering class, where we did the audio for the uh, Raspberry Pi, we used C language to manipulate the amperage. So the C language has been around and it's always going to be. Another language that's used is the assembly. Assembly can be more geared to a specific architecture. So there's going to be always assembly language around. And depending on the different libraries that's available and the type of architecture that's being used, we can say that the assembly language is more used than the C language when it comes to bigger storage like computers. And then we have system programming. This is when we want to do everything from scratch. We want to begin all over, and we decide to optimize the computer as much as possible. But recently, there has been many advancements in computing, so that type of um, low-level design may not be required anymore, except for really, really um, small reasons. What is embedded systems? Why is it important? Well, for number one reason is cost. You can imagine that uh, having a CPU means, well, to have an OS, you have to have a CPU. And if you're going to have a CPU, then the cost of having a CPU is a lot compared to just having a microcontroller. So one thing is cost. And the second thing that we want to discuss is performance and reliability. So the performance aspect of it, it's much faster. It's much faster to um, it's much faster to have an embedded system than have an OS layer and then having the main function being output. Also, it's more reliable because the whole device is programmed to do one thing. There's no errors or, you know, the OS giving it a different task. It only has one task and it's executing it all the time. Well, let's talk about the different platforms. We have host machines, development environments, running test coding. We have compilers and tool chains. We have version control. All this is just to maintain the overall flow of the code that we want to embed. That's that. Let's talk about hardware communication. Microprocessor. The microprocessor itself, if it has a large memory, then it's able to store more. It's able to store more information. But also for the microcontroller, we're able to communicate to input and output devices. So one controller can be programmed to do to send one signal or to perform one set of operation. This way, if you think about airplanes, if you think about trucks and stuff like that, then they want to be able to do one thing at a time. So that's what it is. Classification of embedded systems. There's three different types of classifications. When it comes to that, there's small embedded systems, medium embedded systems, and the sophisticated. With the small, you have a single 8-bit or a 16-bit microcontroller that does most of the job. It may be battery powered because it's just so small that it doesn't consume that much power. But with medium embedded systems, they do consume power, so it might be connected to an outlet. And mostly, um, empirical evidence is showing that the assembly language is dominated in this area. And then we have the sophisticated embedded systems. These sophisticated systems can take up large rooms or large areas and may consist of many different components and may require low level system programming if you wanted to do something specific and have high performance in that area. Examples of embedded systems in our world is like financial services, like the banking, like ATM, airplanes, as mentioned before, elevators. We have biomedical devices always needing embedded systems. So that's a great area to go into if you're interested. We have the LCD display. It's only programmed to do one thing, which is display things. That makes sense. The telephone, microwave, all these devices, they use embedded systems. And that's great. It's very cheap to make. A toy car using embedded systems. The car does not require an OS. There's no operating system built into this car, but it was programmed to do one thing, which is to move. And the basic move operations are left, right, back, and forth. So this is a great example of how an embedded system can be defined to do one thing and be really great at it. So the only thing that this car needs right now is just to be powered. Okay, there goes my references, the works cited page. All right. Does any of you guys have any questions? Thank you so much.